Welcome to video 3, the fundamental theorem of calculus. Now this is very important because it is the fundamental theorem of calculus, but that's what we're going to learn to use today. There are two parts to the fundamental theorem of calculus, and we're doing part 1 in this video. Before we begin, I would suggest that you pause the video, take a moment, and review properties of integrals. This was the last thing that we did on the last video, and we didn't get a chance to practice. So just take a moment and solve these. Pause the video, solve it, and then bring the video back on, and we'll go over it. Welcome back. So in the very first one, notice we're going from -3 to -3. So when we integrate over the same point, remember that that is 0. The integral from 4 to 1 would be the inverse from 4. The integral from 4 to 1 would be the inverse of the integral from 1 to 4. So the integral from 1 to 4 is 9. So since we reverse the limits in number 2, we get -9. In problem number 3, we're going from -3 to 2. We know the integral from 1 to 2 and then from -3 to 1, so we can add those together. So what we're going to do is we're going to add the integral from -3 to 1, which is 1, and then add the integral from 1 to 2, -3, and we should get -2. The integral from 2 to 4, we're going to have to subtract. We know the integral from 1 to 2, and we know the integral from 1 to 4. So I think we have to also do some reversing of the integral, and we're going to get 5. Oh no, I'm sorry. We can use the integral from 1 to 2 and then the integral from 1 to 4 and then just subtract the 2. I'm sorry, I was looking at g of x instead of f of x. And then the last one, 4g of x minus 3f of x, we just find the integral from 1 to 2 of g of x, multiply that by 4, and then the integral from 1 to 2 of f of x, and multiply that by -3, and then subtract those values, -27. If you have any questions about that, you can ask me when we see each other again. Okay, here is the fundamental theorem of calculus, and it basically says if a function is continuous at every point, and we're going to call that antiderivative uppercase f, then the integral from a to b of f of x dx is f of b minus f of a. Now let me just say, you already know how to do this. This is what we've been doing all along since we started integration. We're just giving it a name. This is what we did in the last video. We're just giving it a name. Okay, let's do an example. Now, in order to make this easier to integrate, it would be easier if I wrote this as x to the -2 instead of 1 over x squared. So that's what I'm going to do. I'm going to rewrite that so that I can use the power rule. So I'm going to use the power rule to find the antiderivative, and then I'm going to evaluate that from -2 to 1 to -1. Now what I do with that is, the first thing I want to do is I want to put -1 into the expression. So evaluating at -1, I get 1/2 minus 1. Then when I evaluate at -2, I get 4 over 2, which is 2, minus 1/2. And then I just simplify it to get an answer. Okay, so let's look at the next one. Again, there is no product rule in integration. So please remember, there is no product rule in integration. And so for now, the only thing that we know now are the trig functions and the power rule. That's all we know. So everything that we do, we have to get it in terms of trig functions or the power rule. So let's start by distributing the square root of t to both of those. And I'm going to write square root of t as t to the 1/2. Remember, when we multiply, we add exponents. So I distribute the t to 1/2 to each term. And now I'm going to integrate using the power rule. Now, I didn't, for some reason, didn't write this as it should be written like this, from 0 to 2, because I didn't do a C. But this shows that I'm evaluating this. So the first thing I'm going to do is I'm going to put 2 into T, and then subtract that from 0 into T, which is just 0. And I don't think I wrote that down because it's just 0. So this would be technically minus 0. And so all I did was T to the 3/2 would be the square root of 8, and 2 to the 5/2 would be the square root of 32. You can simplify that if you are so inclined. Okay, once again, I ask pause the video and see if you can get these answers. I don't have the work for it, but just pause it and see if you can get the answers. And then when we meet, if you can't get the answers, we can talk about it. Okay, here's another example, and I think I did this one with you. Basically, we're just going to integrate both of these. Now, cosecant squared x, that's just one of those ones that you have to remember. And I think it's negative cotan x. So it's 2x plus cotan x, and then we're going to evaluate that from pi over 2 to pi over 4. And that simplifies to pi over 2 minus 1. Now, for this one, this is a little different. You can do this algebraically. I don't recommend you doing it algebraically. You can write it as a piecewise function and integrate it algebraically. I don't recommend that. Most of the time when students do that, they make just simple bookkeeping mistakes. What I suggest you do is graph this. Now, from graphing this, we know that we'll have a vertex at 4/3, and it's going to be symmetrical around 4/3. So the graph of this looks sort of like this. So instead of solving this algebraically, my suggestion would be simply to find the area under the curve, because remember, integration is just area under the curve. So the formula for area is 1/2 base times height. So I'm going to find the area of the smaller triangle. So the base of that would be from 0 to 4/3, so it's 4/3, and its height is 4. Now the way that I found that height was by substituting 0 into the original equation. So if I put 0 in for x, I get 3 minus, okay, so how does that 4? If I put 0 in for x, I get the absolute value of -4, which is just 4. And that's how I got this value of 4. And to get the value of 11, I did 3 times 5, which is 15, minus 4 is 11, and that gave me 11. So that gave me the height, and then the base is simply the distance between those two. So that's what I have. This is my height, and this is the base. And so I found that for each triangle. I summed them together, and I got 22.833. Now, when it asks to find the area bounded by the curve, we're going to do a whole chapter on that in chapter 6. But for now, I just want you to see what they're asking you. It's bounded by the curve and the x-axis. So basically, they're asking you to find the area under the curve. So once again, we just integrate that. And I found the antiderivative. I didn't show where I solved it, but you can do that on your own. I simply substituted in for 3. And then substituted in for 0 and got 4.5, or 9/2. Now, I would like for you to pause the video and try this one. Okay, welcome back. So one of the things I hope that you saw was that it was symmetrical. And because it's symmetrical about the y-axis, remember, then we can, instead of writing it this way, we can write it as from 0 to 2 and then multiply by 2. But one of the things that was a little different for this one, when we find the area under the curve from 0 to 2, we also have to find the area of this rectangle as well, or a square. So the total area is going to be the area of this triangle, which is 1/2 base, which is 2, times the height, and the height is the distance between those two, so the height is 2 as well. But we also have to add the area of this square, which is 2 times 2. So what is that? Half 1, this gives me 2 plus 4, which is 6. But I just found the area of this portion of it. To find the area of the complete thing, I have to multiply that by 2, and that's how I got 12. Now here's another just interesting concept that for some reason students struggle with. I'm not sure, but it's the average value. I guess they struggle with it because it really is easy. It's just a matter of memorizing the formula. So if I have a function 1/2 x squared, and the area under the curve is 9/2. The average value is the area divided by the interval. So the average value is the integral divided by the interval. So the average value is given by the formula 1 over b minus a times the integral from a to b of f of x dx. And to simply just memorize the formula. Memorize this formula. That's all you have to do is just memorize the formula. And one of the ways to help to remember it is the integral over the interval. It's the integral over the interval. So here's an example, and look, you already have the answer. But we're going to set it up by doing 1 over 4 minus 1, because that's the interval, divided by the integral from 1 to 4, 3x squared minus 2x. Now, I didn't show you how I did this, but this is basically just integrating this. Then that gives me x cubed minus x squared. Oh, that worked out beautifully. And I'm evaluating that from 1 to 4. And I'm multiplying this whole thing by 1/3. So I would evaluate that, and that gives me what? 64 minus 16. Then 1 minus 1 is just 0, so 64 minus 16 is 48. Then I divide it by 3, and it gives me 16. And that is that. In your notes, you have this free response problem. I would suggest that you take a moment and work on this free response, and then come back in a minute, and I will give you the answers to the free response. Okay, so here are the answers to the free response. The first one is to find the average value. And I can't remember what the others asked, but here are the solutions. And again, if you have questions on this, you can come and see me, or you can ask me the next time you see me. I would suggest that you complete the FTC worksheet for more practice, which is in your packet. And that's it for this video. I will see you in the next video.